Hi everyone, how's it going? I hope you are as fit as a fiddle. Welcome to this video. This is the video part number 4 from the test-driven development video series, and if you didn't watch the video part number 3, you should watch it at first and then watch this video. Okay, what's on the agenda in this video? Today we are going to test drive a Soundex class. Alright, what is a Soundex? Soundex is a phonetic algorithm that can improve the search capability in an application. Searching is a common need in many applications, and an effective search should find matches even if the user misspells words. For instance, suppose in the search text box of your application, a user typed something like this, Robert. Your application should also search Robert, because these two words have the similar sound. Maybe the user misspelled the word. Okay, what Soundex algorithm does? The Soundex algorithm encodes words into a letter plus 3 digits. Actually, it maps similarly sounding words to the same encoding. Here are the rules for Soundex based on Wikipedia. The algorithm should retain the first letter and drop all of these letters. The algorithm should replace consonants with digits with these rules. It should replace these letters with 1. It should replace these words with 2, and so on. Okay, the next rule. If two adjacent letters encode to the same number, algorithm should encode them as a single number. And also, it should do same if two letters with the same number are separated by H or W. But the algorithm should encode them twice if they separated by a vowel. These rules also applied to the first letter. Okay, the final rule, the algorithm should stop when you have a letter and 3 digits. And if it's need, it should also do 0 pad. Alright, remember the TDD cycle. We're going to implement it through TDD cycle. But let me tell you something about a common misconception of TDD is that you first define all the tests before building an implementation. Actually, it's not true. In TDD technique, you should focus on one test at a time and incrementally consider the next behavior to drive into the system, like what we have done in the last sessions. That is exactly the TDD cycle. Write a test, get it to pass, and improve the design, and do it again. Okay, let's implement it. But before that, check out the session 4 branch. Open up the Visual Studio Code, and on a status bar, click branch button and session 4. Okay, the Soundex algorithm had 4 rules. And there is a question here, where do we start with test driving the Soundex solution? Let me tell you. As a general approach to TDD, you should seek to implement the next simplest behavior in turn. Okay, let's quickly review the Soundex algorithm rules. I'm going to start off with rule number 3, but it appears most involved. Okay, rule number 4 indicate when to stop encoding, and I think it would probably make more sense once the implementation of other rules are completed. Okay, the second rule says that the first letter should already be in place. Okay, we should start off with rule number 1. It seems more straightforward. The first rule tells us to retain the first letter of the name and... Okay, don't read anymore. Keep things as small as possible. We can also imagine we have a single letter vote for the first test case. Okay, let's test drive that scenario. Back to the code, create new source file. Soundex test.cpp. Alright, we should also add this new source file to our build system, I mean in CMake list file. You should add this new source file to this point, I mean line 11. Soundex test. I drop one letter, let me rename it Soundex tests. Alright, as you see, the CMake extension configure the project automatically. Okay, back to the code, include gtest header file, and we also need gmock header file. I will tell you why. Okay, as you saw in last sessions, we have declared a kind of class for common setup and variables in test scenario, which is called test fixture. We can also declare text fixture here, Soundex encoding. This is our test fixture. We should also inherit from test class. Alright, let's implement the first test case. Testf macro, test fixture name, and then test case name. Retains sole letter of one letter vote. Okay, you can read the test fixture name with test case name together, left to right. We can read it like this: Soundex encoding retains sole letter of one letter vote. Actually, it reveals a sentence that describes what we want to verify. Okay, let's implement this test case. Suppose we have a Soundex class, create an object, and we can imagine this object has a function which is called encode. It takes a string, we give it a one letter vote, and it returns an encoding. Okay, and finally we can verify the encoding with asset equal. Okay, I'm going to use a new kind of assertion which is called handcrest matcher. We can use handcrest matcher through asset that. The first parameter is the subject under test, or the value, and the second one is a matcher. We can use equal matcher. Equal takes one parameter, and I can pass the result. Okay, what's the difference between handcrest matcher and those kind of ordinary matcher we have used in the last sessions? Actually, There's no difference between these two kind of a session, but ham crisp match is more readable and it produces the more readable output. If you just run the test cases, you will find that. Okay, remember the TDD cycle. First step, implement a test case and make sure it's failed. Okay, let's compile the project to make sure it's failed. Alright, the compile is failed. The compiler says that we need a Soundex class. We could add a compilation unit like a header file or source file for Soundex, but let's make life easier for ourselves. Instead of mocking with separate files, we can simply declare everything in the same file as a test. Once we are done, we will split the test from the production code. Okay, the next step, get it to pass. Let me tell you something. This approach also is in keeping with Uncle Bob's 3 rules of TDD. Alright, what those rules are? Okay, here we have the Uncle Bob's 3 rules of TDD. The first one, write production code only to make a failing test pass. This is just we're going to do right now. The next one, write no more of a unit test than sufficient to fail. Compilation failures are failures. This is what we have done in the previous step. And the third one, write only the production code needed to pass the one failing test. And it is a little same as the first one. Okay, back to the code and pass the test case. Declare new class Soundex. It should have a function which is called encode. It should return string and take a string as parameter. We should also include a string library, and we can return the input to pass the test. Alright, and now we can run the test case. Alright, this is the Soundex encoding first test case and it's passed. We are done. Alright, final step, clean up the design. Are you kidding me? We wrote 1 line of production code and 3 lines of test code, and what's wrong? Okay, it's extremely easy to introduce deficient code even in a small number of lines, and TDD provides the wonderful opportunity to fix such small problems as they arise before they add up to countless small problems or even a few big problems. Okay, take a look at the code and test case. I think we can turn this asset function more readable. We could use a using directive to help us to do that. And now we can remove this part. Why I've done that? Because same as the test declaration, I mean test fixture name and test case name that make a sentence to become more readable, we want our assert to do the same. Alright, what we have done so far, it's called unit testing. In the test-driven development world, there are a lot of kinds of tests, like integration tests, acceptance tests, end-to-end tests, and so on. I want to play part of a video from Fedor Pikus for you. He will explain to you about different kinds of tests.
Not as simple. So, since I brought up the subject of did we create more tests or different tests, what sort of different tests can we do? Well, there are unit tests, and that's a test for testing a small bit of code or a logically isolated bit of code. We'll talk more about that in isolation. Integration tests, tests for interacting of several components. System tests for the entire software system. By the way, not consistent terminology here. You may find the word system testing used to mean what I mean integration testing, and you may find the words end-to-end testing used to mean what I call system testing. There is this thing sometimes called point test. Again, there is no established terminology here. It's kind of like a unit test, but you use the rest of the application as a test driver for the program. Basically, you run the entire program or a part of the program, but you carefully select the input data to test one small chunk of your code. Acceptance tests. This verifies that you pass certain requirements. Regression tests tracks for changes where you don't expect them. Performance tests can be any of the above. You tracking performance of your code. Performance is as much of a goal. I'm not talking about benchmarking. I'm talking actually about you have a performance requirement. It could be as much of a goal as a correctness requirement. This code must produce correct result and must run this in this time. And these are your requirements. Both need to be tested. Now, it's important to know the difference. In reality, one of the most common reasons for basically abandoning your test suite and not giving up on it is trying to use the wrong kind of test for the wrong purpose. So, for example, if you start using unit tests as system integration tests, you will probably in the long run will be unhappy with the results. It will be unstable, it will be too hard to maintain. It's very easy to start doing this, and it's very hard to keep going.
Okay, that's all we have time for this video. In the next video, we will try to complete the SoundX algorithm implementation through TDD. I hope you enjoyed it. Thanks for watching us. See you soon.